Hey everyone, John here, lead maintainer of the open source software engineer career development platform Latterly.io. You can sign up for free and use the career journal. Join the Discord, network, grow your network, job search tips, the works. Let's work on LeetCode number 981, time-based key value store. This problem reads, design a time-based key value data structure that can support multiple values for the same key at different timestamps. So I'm already imagining a hash map, a dictionary, something like that, where the keys are effectively timestamps. But the value could be a set, it could be a list, it could be another dictionary, so we're going to be able to support multiple values for a particular timestamp key. And I can see that timestamp will be an integer. So we're going to support multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. Okay, so within a timestamp, I could have a dictionary of key value pairs. That would give me different items at different timestamps. Or I could do the inverse. I could do keys at the top level and timestamps in. Either way, it looks like we're looking at nested hash maps. It's going to be an initial data structure that comes to mind. Okay. So we want to implement the time map class. It comes like this with this few methods kind of already there for us in Python. We want a void set method. The signature is already here, cool. And we want a get method which returns a string. It returns the value such that set was called previously with timestamp priv less than or equal to the timestamp. Okay, so I don't need to get that exact timestamp. I'll check for that, but if it's not available, I would want to get sort of the freshest or most recent timestamp. That's interesting. So there will be some sort of a loop logic there. If there are multiple such values, it returns the value associated with the largest timestamp. That is the freshest, most recent. It makes sense. If there are no values, return an empty string. Okay. And then we have an example here. Cool, let's get to work. So I would like some kind of a root node. We'll make classes if we need to, but I'll just go with a dictionary for now. And this will be time and then values at time, which is going to be another dict. And that latter dict will be string, string. So I can see the key and values are always string, string. Cool. So for set, what happens if it's already there? Do I error? Stores the key with the value at the given timestamp. It sounds like it will be overwriting. So we'll see if we fail some test cases. But it seems like I don't even need to check for presence. I can just write. I can just straight up write it. So I'll do time at the top level. So here I will say self.root at timestamp is itself or a new dictionary if it doesn't exist. And here this will error if it doesn't exist, so I'll use the get operation. And we will default to an empty dictionary if it's not there. So either way, we're going to get this dictionary and then set it to itself or an empty dictionary. And now I can access that timestamp as a dictionary with this new key and set a value. Okay, so I think that's everything we need to do for the set. For the get, I want to get, interesting. Since I have time at the top level, I'll need to loop through multiple timestamps. I guess it's still not that performance intensive because we're doing O of 1 lookups at each level, so I think that's fine. So if the timestamp is there, we'll check that one. And then we want to loop backwards. So really, this could be kind of the max time. Yeah, let me check if it's there. Mark says, what are you preparing for? Just doing LeetCode, practicing LeetCode. How about you? Welcome in, by the way. Hey, if you're liking the video so far, you can tap like to help the algorithm send it around. You can also follow the page. And I'm checking the chat. Question mark muted. Oh, am I muted? I don't think that I'm muted. Can you hear me on Twitch and TikTok? Hi, seems you're muted on Twitch. Bummer. Only on Twitch I'm muted. Okay, I don't know why. Thanks for reporting it, I guess. Mark says, I'm a data engineer. Hey, we love data engineers too. Is this more software engineering? Yeah, this is more software engineering. Web development, not just web development, back end, front end, full stack, product engineering. A lot of these different roles will get LeetCode interview questions. So this is a platform called LeetCode if you're not familiar. All sorts of software engineers will get questions on this platform. You can also check out Hiring Without Whiteboards for software engineering roles that don't necessarily need LeetCode. This top GitHub right here. So if you are not into LeetCode, but if you're in the software development job families, you can check out these companies. Okay. So really, I just want to loop through all the timestamps. So for time in self.root.keys, and I could go for items. So this will be for time and time or values at time. If time is greater than timestamp, we just want to continue. And I want to loop in reverse. So here I'll say rev items. Let's see, I can get the keys. This is nlogn. So that could be a performance constraint. We'll see. Got a typo in the word reverse. Reverse. So probably binary search is going to be better. Let's go with this for now. We'll get it working and then we'll optimize it later. So if the time is greater than the timestamps, we continue. Otherwise, otherwise I'll get the dictionary. And I'll say if the key is in cur dictionary, then I can return this. And then if we get all the way down here, we'll return an empty string. How does this work? Dict keys has no attribute sort. Can I do... Can I just cast it to a list? Okay. Are we going to get a time limit? Oh no. Okay, so we got a bunch of them passed, but we got a time limit exceeded. Okay, so how can I do this faster? Well, I could keep a list of the keys and do a binary time insertion. That seems like a slow way to do things. Let me see. Are they always listed? Are they always listed in sort order? Let's try this. Let's try using a while loop, a backwards while loop. So while I is greater than -1. I'm just going to try looping over the keys in reverse order and trusting that when they're cast to list, it's automatically sorted, which I'm not sure about. So we're starting at the top, and then we will go I minus minus. That didn't work. Minus equals 1. Greater than, not supported between module and int. Oh, I did this wrong. Yeah, that should be... Okay, that worked. Interesting. The Goat, thanks for the follow. So we still got a time limit exceeded using the reverse I. Okay, so what I can do... Oh. Wow, we got a time limit exceeded pretty quickly there. So I think what I can do is a binary search here. So let's change this up to a binary search. So... right, left, medium. Right, left equals 0, and middle equals R plus L. Let's see. We can do the middle. We can do the M inside of the while. So M is R plus L, and the floor division of 2. The while condition will be while left. Oh, well, yeah. While left is greater than, no, while left is less than right. So whenever they cross, we'll be done bisecting everything. Okay, so here I want to get the time at M. And then I'll say if time is greater than timestamp, that means my target is to the left. So I want to select the left window. So the next middle should be left and middle. So right becomes middle. Okay. Else if time is less than timestamp. Here I'll probably want to track the best time. Which will be 0. No, that'll be -1. Let me know, bro. Would love to hear your thoughts once you wrap up this problem. Did you like working at Upstart? They reached out to me about an analytics engineering role. I liked my time there. Yeah, it was pretty good. So here we want to return that if best time is equal to -1. In other words, we never found a match. Else, self.root at the best time at the key index. Okay. So if we ever found a best time, we'll use it. Otherwise, we will go for the empty string. All right. So here's the current time that we're looking at, and if that's too large, then we're immediately going to point the right to the middle, and we will iterate so that the middle bisects the next group there. Else, all this stuff needs to get indented. Okay, else, best time is the max of whatever it currently is, and M. Okay, so we'll update the best time. Actually, we can check if it's an exact match and then do this else over here. So if it's exactly equal, we'll just go ahead and return. So if it's greater, we're going to move the window to the left. If it's the right time, we'll return now. Otherwise, it's not the exact time, but we want to find the freshest one. So we're going to bisect to the right from the left window, if that makes sense. So we'll keep track of this best time. And now, let's see. In this case, the time, this should be called like target time or something. No, this is the current time. The current time is too large, so we move to the left. Here, the current time is too little. Current time is smaller than desired. So then my left pointer becomes middle. And I will, that's all I need to do, right? I think that's all I need to do. Let's see. Oh, this seems to be taking a lot longer than I expected. Do I have an infinite loop somehow? Okay. So I'll do an off by one adjustment. So the time is greater than the timestamp. Oh, thanks for the follow. So instead of setting the right window equal to M, I can do M plus 1 or minus 1, which is the right thing to do here. So I want to move my right to the middle, and then I want to off by 1, so I'll do minus 1. And then here, I want to move my left to the middle, and I'll do plus 1. Key error 0. Okay, so we should only set the best time if the key is confirmed to exist at this time. So if the key is in self-root time, then the best time can be this max operation. I'm still getting a key error of a 0 here. Let me write this differently. So somehow the key is in self-root time. Oh, because I said best. What's going on here? All right. Why is this not working? I have my binary search syntax is messed up somehow. All right, let's ask chat. One thing I could do is I could roll back to the list approach and then don't start I at the end. That's another thing that I'll try. Let me try that before I go check on what chat says. Have you tried Claude for coding? I think it's better. Yeah, maybe it's better, but they're both good enough, so it doesn't matter. So here I said I is the length. Here let's say that I is the minimum. Nope, that's not going to work because I tried looping backwards. Let's see. Short answer, yes. Okay, great. Okay. I was assuming that this is sorted. That's the issue. Still potentially in the worst case. Oh, because I didn't have equal. Oh, that was it? Okay. I think I'm still going to get a time limit exceeded. It's still in the worst case. Okay. Again, this is closer. This can miss a closer earlier timestamp that has the key. Store for each key a sorted list of timestamp value pairs. Ooh. So I did a dictionary of dictionaries. Yeah, this is better. LeetCode guarantees non-decreasing timestamps per key. Okay, so it would have been better if I did the key at the top instead of the time at the top. This bit is weird. All right, let's try it again and do the key at the top. So here I'm going to do the key, and and switch the timestamp over here. So now I'm putting the key at the top. Oh man, and I'm not supporting multiple. That's the big problem. So it'll be this. No, this should still be okay. Chat is saying that I should use a list. All timestamps are strictly increasing. Yeah, that's an important detail that I missed. There you go. So then we don't need binary time insertion. So now that I'm dealing with a list instead of a dictionary, now I can bisect it properly. Okay, cool. So times, let's get rid of this whole method basically. Times for key is self.root.get key. So now I'm guaranteed to have times for key. So this is from, to, and step. From, to, and step. Here we're not bisecting, but I think it otherwise follows the logic. No, I got another typo somehow. Thanks for the likes. From, to, step. Should I be stepping like this? Key index out of range. Okay. Oh, we got more passed, but we got a wrong answer still. Is it because I should be stepping like this? No. The get can fall off the end of the loop and return none. What does that mean? This. What does it mean it can fall off the end of the loop? This happens when all stored timestamps are greater than the queried timestamp. Oh, I need to have return. Okay, I see what it means fall off. It could, okay. It can just get through it and not find a value. That makes sense. Okay, so this is pretty good. I think I can get a little faster if I bisect. So let me try my, that worked, but let me try my right, left, middle thing. While left is less than or equal to right. That's something I need to remember. Then the middle will be their floor average. Okay? The current time is here. And this is wrong. Interesting. Oh, why does it say bar 2? So if the, oh, because I need to do, now that I'm doing the bisection, I need more conditions. So if the current time is less than the timestamp, then the left window should be moved up. And we want to offset it this way. This could still miss something, yeah? No, because in this case, we're guaranteed that every time has a key. Why is it way over there? This is supposed to be more efficient. Hold on. Oh, that's funny. Okay, so we're bisecting, but bisecting is slower. How weird is that? All right, well, we did it. I think that's the part that I care about. It's just going to be a coincidence of the test cases, I think. Your workload and Python's overhead make the reverse scan hot path cheaper. Yeah. We could do a reverse. No, there's no way to reverse it. Yeah. Glubs says, hi. What up, Glubs? Chill guy. Hey, long time no see. Thanks for coming back. What's your favorite web dev tech stack? I like Next.js. That's what Latterly uses. It technically uses the T3 stack, if you're familiar with T3 stack. So here's the T3 stack. But it's going to be using Next.js with React Query. Tailwind, gotta have Tailwind. We love Tailwind. And Prisma. I use Prisma, not Drizzle. And then I like Supabase a lot. I like Supabase a lot. Is Python Django Flask solid? No, it's trash. If you're using Python, you should be using FastAPI. That's amazing that I hit this typo and it still showed up. FastAPI is the GOAT. You should be using FastAPI for Python. For the ORM, I like Sequelize. Oh, sorry. Sequelize is also TypeScript. I like SQL Alchemy. Like SQL Alchemy. You can use it together with FastAPI, right? It's part of the same stack. They're not alternatives. And then Alembic. You can even go to the FastAPI docs and it'll talk about SQL Model, SQL Alchemy, and Alembic. SQL Model has migration utilities wrapping Alembic, so you can use all of them together. It's not like you need to decide between them. Isn't this clean? Check this out. How clean is that? You love to see it. If you're in Python world, you got to know about rough. This is going to be your linter. And you got to know about UV. This is going to be your package manager. Shout out to Astral. Astral is the organization that maintains rough and UV. Things rock. These things rock. All right, y'all. Oh, Morax, are you trying to make your code more efficient? First mistake is coding in Python. That's a good one. That's a good one. No, we did everything that I wanted to do. We passed the thing, right? We got the green marks. We're good. Although it was surprising to me that the bisection was slower. But anyway. Thanks for being here. Hope you all follow the channel. See you next time.